Alright class, we are getting close to quiz time on sections 2.2 and 2.3, so here is a recap video, at least the first half. We are going to recap 2.2 and 2.3 to review, and then we'll finish up this video with some new material that you will need to begin the next section. So, review. Consider the function f of x equals x minus 1 over x plus 2. Alright, well, hopefully we remember, if we want to know if a point is on the graph of f, well then we need to plug in an x value, plug in an input, and see if the output that we get matches with the output that we have in this point. Okay? So, we're going to do f of 0. And then what are we going to do? We're going to basically plug in 0 into both spots of the f function. So 0 minus 1 is negative 1. 0 plus 2 is positive 2. F of 0 equals negative 1/2. Well, what do we see here? We want to know if the point 0, 1/2 is on the graph. This is telling me that on the function, a point would be 0, negative 1/2. So, no. Alright. Why? Because the outputs don't match. Alright, so that's kind of what we're looking for here. If we got 1/2 and that was 1/2, then yes, that would be a point on the graph. Now, excuse me. Now, on letter B, if x equals 2, what is f of x? Alright, this is really similar to this. We're just not doing any testing. We just need to say, I'm going to input 2, and I want to get the output. So, f of 2 equals, well, what do I get? 2 minus 1 is 1, and 2 plus 2 is 4. So 1/4. So now I know that that f of 2 is 1/4. How do I finish this problem up? What point is on the graph? Well, this was my input, this is my output, so 2, 1/4. Moving right along, what do we notice that's different in C? Hopefully you just said that I'm giving you the output now. Okay, I'm not giving you an input, I'm giving you the output. So that means we have to plug in 3 for the entire left side. 3 equals x minus 1 over x plus 2. And now we need to solve. Now if you remember correctly, the easiest way to go about this is to, let's do this in another color, make that left side a fraction and cross multiply. Okay? So, this one's nice and easy. X minus 1 times 1, well that just stays x minus 1. What happens when we do 3 times x plus 2? Alright, we get 3x. Please, 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 please be careful. It is not plus 2. You have to distribute the 3 to both pieces of this quantity. So this should be a plus 6. Now, if we keep going, I'm going to move my x's over, so I'm going to have negative 1 equals 2x plus 6. I can keep going. I can say this is negative 7 equals 2x. I can finish this by saying x equals negative 7/2. Alright? To finish this, though, let's see what it asks. It says to find that point again. So we know that we got an x value of negative 7/2 when the output, or when the y value is 3. So we just write it, negative 7/2, comma, 3. Lastly, what are the x-intercepts? There's a couple of ways to think about this. I'm going to go through the long process and then kind of explain the shortcut. So if we want to get the x-intercepts, that's the same thing as y equals 0 or f of x equals 0. So we're really going to do the same thing that we just did over here, but instead of plugging in 3, we're going to plug in 0. So 0 equals x minus 1 over x plus 2. Now, similarly, I would make this a fraction. I would cross multiply. X minus 1 times 1 is still just x minus 1. 0 times absolutely anything is just 0. So I solve and I get x equals 1. Which means my x-intercept is 1, 0. Alright, now again, the shortcut, if you want to really think about it. every time we do this, what's going to happen when you multiply this 0 by the denominator? This is going to go to 0. It's going to go away. So really what we're finding always, always, always are the zeros of the numerator. Notice how our original was x minus 1, and what was our x-intercept? 1, 0. We got that right from the 0 of the numerator. Alright, moving right along. Now we're going to graphs. Now we are going to graphs. Okay, so use the graph to answer the question. What is the domain? Well, what are we saying here? I'm going left forever, which means I have to start at negative infinity. And I'm going. There's no holes. I'm going right forever, so this should just be negative infinity to positive infinity. How about range? Well, range, again, don't think anything left-right. Completely forget left-right. We're only going up-down for range. So what do we notice? It's going down forever. It's also going up forever. There are no holes. So our range is also negative infinity to infinity. Now the intercepts, please take note. I think they're slightly off on the graph. I think everything was kind of shifted a little bit. So I'm going to actually say that this one is supposed to be about here, and this one is supposed to be about there. Okay, so we will say that I have an x-intercept at negative 4, 0, and then a y-intercept at 0, 2. That's goofy. I don't know why the graph messed up like that when I copied it. Okay. But again, it says intercepts, so I want both, right? I want x and y. How often does the graph, or how often does y equals 2 intersect the graph? Well, there's a couple ways to do it. You can either draw in y equals 2, which is a horizontal line, or you can just kind of go through and see, okay, well, here I have a y value of 2, here I have a y value of 2, here I have a y value of 2. Either way, it's not even asking for the actual values that lead to y equals 2. They just want to know how many times it happens. So, 3 times. Alright. Now, f of 4, again, this is going to be a little bit sloppy because of the graph being off. F of 4, 1, 2, 3, 4, okay? Again, f of 4 means I'm inputting 4, or my x is 4. And then I will say, and again, I think everything was just shifted down a little bit, so I'm going to say that it was right about there, which means I'm going to say that f of 4 is equal to 3. Lastly, for what values of x is f of x greater than 0? This is the one that I know we were having some trouble with. Just remember, if f of x is greater than 0, then it has to be above the x-axis, right? So put something there to understand that. Maybe a pen or post-it notes. Don't make fun of my post-it notes. And you need to describe everything above, right? We want it to be greater than. Now, we said from earlier that we have this intercept at negative 4. So I know that that's where it's going to start at. Alright, I know that's where it crosses the x-axis. Do I include the negative 4? Do I put a square bracket or a parenthesis? I put a parenthesis. Why? Because it has to be greater than 0, not greater than or equal to 0. And then what happens? Does it ever go down or below 0 again? No. So negative 4 to infinity. Alright. Anything on the quiz will definitely be easier to read than that. I'm extremely sorry for that example, guys. Okay. Part 3, or number 3, I should say, sorry. Okay. Let f of x equal square root 2x minus 4 over 3, g of x 5x over 8. Okay. F over g, or f divided by g. So remember my suggestion. When we have fractions, when we're doing this division, the division operation of functions, and we have fractions, I like to write it the old way. Right? I want to do 2x minus 4 all over 3, and then divide it by 5x over 8. And again, the reason is I don't want to make a complex fraction. I don't want to put fractions inside of fractions, because I know what I can do when I see division of fractions. I can keep, I can change, I can flip. So I can keep going and I can say keep, change, flip. Alright, now when we're multiplying fractions, it's nice and easy. You just multiply top with top, bottom with bottom. So 8 square root 2x minus 4 all over 15x. That is f over g of x. Now it does ask for the domain. Remember, when we do these operations of functions, you need to check for the domain everywhere, okay? So let's take a look at f of x. Yes, we do have a restriction from f of x. So that means 2x minus 4 must be greater than or equal to 0 because it's a radical in the numerator. We keep going, we say 2x must be greater than or equal to 4, or x must be greater than or equal to 2. Cool. From the original g function, there is no restriction, right? No restriction. When we keep going and we look everywhere throughout, okay, here we go. I see a restriction here. These are going to be the same restrictions. 5x or 15x in the denominator will get you to the same result. So it doesn't really matter which one you look at in this case. 15x cannot equal 0. If you chose, you would just do 5x cannot equal 0, and either way, you get x cannot be 0. So now the last thing, because we have a couple of things, I would want to maybe draw a picture of this. Here is 2. I know I have to be greater. And here's 0. Do I need to include 0 when I'm writing the restrictions? No. I'm already only looking to the right of 2. So 0 is already not included. So for my domain, I would just say x must be greater than or equal to 2. Or if you want to go with the new route, we could go to infinity. Sorry, a little bit off the page there. Alright, now, algebraically determine whether the following functions are even, odd, or neither. What you have to do here, always, is find f of negative x. Okay, we're going to find f of negative x. So, f of negative x here, and then I plug in negative x to the 5th minus 2 negative x cubed plus 7. Well, this is going to go to negative, so negative x to the 5th. This will be negative x cubed times a negative 2 will be positive 2x cubed plus 7. What happens? Are we completely opposite? So these are definitely opposites, right? Original to new, opposite. Negative positive, opposite. Ooh, positive positive, plus plus, nothing. That did not switch. So because we're not completely the same or completely opposite, we are neither. Okay, we are not even or odd. We are neither. We move on. We try it again. Again, we plug in. Well, this becomes positive. This is negative. Okay, so f of negative x. All right, what do we see? Same. Ooh, these are opposites. So we're not completely the same. We're not completely opposite. So again, this is neither. Last one. F of negative x equals 5 negative x over 2 negative x squared plus 1. If we clean this up, this becomes negative 5x all over 2x squared plus 1. Now remember, I asked you guys to try, when you have a negative in the numerator, to kind of factor it out or bring it out front. Because I can rewrite this. F of negative x is really just negative 5x over 2x squared plus 1. And why am I doing that? Because hopefully we agree that these fractions are the exact same, however this one is negative. So these are opposites, which means that this is an odd function. Alright? Alright, so intervals of increasing and decreasing. Last part before we move on to some new stuff. just remember, what do I mean? I really just mean, where am I increasing, where am I decreasing? Or where am I going up, where am I going down, where am I staying the same? Hopefully we agree from this picture, we're never staying the same. Okay, so I know I'm not going to have any section of constant. Let's see here. Right around -3, I'm going to say, is where my graph switches from decreasing to increasing. So I know that this section is my decreasing, so let's describe it. I have a closed circle at x is equal to -5. So I am going to close my bracket, and I decrease all the way up to -3. What about increasing? Well, I start increasing at -3, and again, it's a closed circle, so let's bracket it. And I increase all the way till x equals 2. And again, it's closed, so I bracket it. Alright, so make sure to go back over anything you need to review from this recap video. All of this is fair game for your quiz. Now, some new stuff. Composing functions. This is different than operations with functions. Operations with functions is you're taking two functions, you're adding them, subtracting them, dividing, whatever. Composing functions actually means that you are putting a function into a function. Alright, so this is where your skills on evaluating functions, when we were evaluating and putting quantities in, it's going to be very helpful in the next day or two. Today we're going to just use numbers to kind of get the gist of it, but we're going to move on and we're going to start putting actual functions into other functions. So Miss Braytek had a great example. I tried to make my own. I was practicing how to draw this and I just couldn't figure it out. So I'm going to go with her video or her example that I thought was pretty good. So just imagine you have some piece of food here and we're going to call that X. Okay? And what's going to happen? Well, some little fishy is going to come by. Oh gosh, this is terrible. Named G, and he is going to eat that piece of food. Well, what's going to happen after that? Well, a bigger fish is going to come by. Oh my gosh, I can't draw. Whoa. Something like that. And he's going to eat that fish. Okay, so what am I kind of trying to say here? Well, technically, only the G is getting X, right? But then what's happening? Well, F is going to eat G, so F is also getting some of that food. All right, but what's important is that you kind of go from the inside and out. You could keep going, right? I could draw a shark. I'm not drawing a shark for you. No, not good. Okay, but yes, you could keep going with functions and on and on and on. So it's going to look like this in the book. F of G of X, or fog. Some people will call it fog. I don't like writing it like this. I want you to understand that you are going to start with the F function, and the G function is going inside of it, okay? I'm rewriting this, F of G of X, so it's F of G of X. All right, I'm putting the G function into the F function. So how does that work? Well, when we move on, I'm going to start by rewriting this in my new way, okay? I'm going to rewrite it as F of G of 1. Because now what I'm going to do, hopefully you guys are kind of seeing this, I'm going to plug 1 into my G function. And what do I get when I plug 1 into my G function? Well, 4 times 1 is 4. Okay, so F of 4, this is nice and easy now. This is nice and easy. F of 4, we just plug in to the F function now. So 4 squared is 16, 16 times 2 is 32, 32 minus 3 is 29. F of G of 1 equals 29. What happens if we switch the letters? Well, let's take a look. Will it be the same? So I know my G function is the outer, and I am now putting f of 1 into my g function. So what do? I again start with my g function, and I plug 1 into my f function this time. So 1 squared is 1, 1 times 2 is 2, 2 minus 3 is negative 1. Alright, so now I am taking that output from the f, and it is now my input into the g. So negative 1, 4 times negative 1 is negative 4. So g of f of 1 is equal to negative 4. Different, huh? Okay, so please be careful that you go in the correct order. Last example is just an example showing you that it is absolutely okay to put the same function into itself, okay? So this is really f of negative 2. So I have f, and then what do I have to do? I have to put negative 2 into the f function. So negative 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5. And now it tells me to put 5 back into the f function. 5 squared is 25, 25 times 2 is 50, 50 minus 3 is 47. So f of negative 2 is equal to 47. Alright, so that's when we give you functions. We can also give you charts and graphs, which we'll look at right now. We're still going to rewrite. Okay, so this is still f of g of 1, but now instead of plugging values in and having to calculate, I'm literally going to use my chart. So it tells me that I need g of 1. Alright, it tells me that I need to get the value of g of 1. Well, here are my inputs, so I'm going to input 1 into the g function. The g function is the bottom, so input of 1. Okay, so when I input 1 into the g function, I get a 0. Now, I keep going. F of 0, okay, so now I go to the input of 0 into my f function, which is this middle, or the top, so negative 1. And I finish by writing f of g of 1 equals negative 1. Alright, we keep going. F, g, negative 2, f of, okay, g of negative 2. So I plug in negative 2 into the g function, I get a 3. And f of 3 is now my input of f function 5. Okay? Let's keep going. Hopefully you guys can just do these on your own now. You don't even have to wait for me. G function, and now f of negative 1. Negative 1, plug into f, negative 3, and then g of negative 3 is 8. And lastly, we have g of negative 2. G of negative 2. So g of negative 2 should be a 3. So that's the in. And then g of 3 is 8. Okay? So, almost done. The last thing I want to do is just show you how this is really the exact same thing when you have graphs. Okay? It doesn't change much. You just have to be careful and kind of think about what you have here. So, it tells us right here that this is f of x, this bottom absolute value looking one. I'm going to label it better just so I kind of remember. F of x is my bottom, and g of x is my top. Now, it still wants us to rewrite, so g of f of negative 1. So I need to find f of negative 1. So if it's an f function, then I need to input negative 1 into this bottom graph. So negative 1 is here, which has an output of 1. So I write a 1. Now what do? I take the input of 1 and I put it into the g function. So my g function is the top. When I input 1 or an x value of 1, I get 4. Let's keep going. Again, if you feel like you've got this, you can either stop the video or just practice these on your own quickly. F of 0 is 0. Okay, so if f of 0 is an output of 0, I do that, and now I need to find g of 0. let's see here, g of 0 here looks like 5. Beautiful. Alright, keep going. Again, be very careful and deliberate with your work. Make sure you're showing me all your steps so I really see that you understand what you're finding and what you're plugging in where. So if g of -1, g of -1 is here an output of 3. So now I need to find f of 3. So I input 3, or an x value of 3, into the f function, and it looks like -1 to me. And lastly, f of g of 4. F of g of 4. So I need to find g of 4. G of 4 is right here at 2. And then I plug 2 into my f function, which is down here, with an output of -2. Okay, so this is just a brief introduction to composition of functions. We will, of course, practice it more. I think that's it for right now. As usual, make sure to email me or ask me questions if you need any clarifications. Peace.